Hello, welcome to the OCP Global Summit. I would love to be there with you, however things beyond my control didn't allow me to do that. Neither me or Song to be there. And nevertheless, we will go through this Universal Baseboard OCP Accelerator module presentation. I hope you enjoy it. Open standards and programmability will drive fast industry adoption and development for large-scale training. Under the OCP principles, efficiency, scale, openness, and impact, the concept of Universal Baseboard for OCP Accelerator modules allows a reduction of the overall research and development costs and infrastructure. This concept also defines common interfaces of a typical OAS baseboard and provides maximum efficiency for baseboard development. UBB is also designed to efficiently include up to 1,000 of nodes given the disaggregated architecture and scale of features. It also changed the form factor for artificial intelligence infrastructure and will maximize the capability while reducing investment from customers. I think that also will increase the innovation ratio. This talk will cover the concept of UBB. It will give a brief spec overview, will review the mechanical assembly, and cover a range of topologies that can be used or that can be built inside of UBB. Let us first think where the UBB lives. So UBB is part of a wider system, which is the Open Accelerator infrastructure. This system has as a heart the Open Accelerator module, which contains the silicon that provides the accelerator capabilities. We need to connect this open module to a host where the CPU has all the software that does the magic for the artificial intelligence. So the Universal Baseboard needs to define host connectors, and we also include a board that does the bridge to condition the signals that are coming from the host to be ready for going to the baseboard. That board is the host interface board. Inside that board, we also put all the security and management of the whole system. The OAI system, of course, needs power, so it receives either 120 or 240 AC power, and does the DC conversion to deliver 12 or 54 volts. And finally, the OAI system has a set of connectors that enable similar or systems of the same type to be connected together to build larger modules. Okay, why do we need the UBB? The UBB is, of course, as being part of the system or OAI system initiative. We wanted to be agnostic of the vendor that provides the module. Then we need to define a common interface for different OAM modules and to be capable to define various interconnect topologies. We've been working in this effort through the 2019. We give the first release in October of the last year, and we plan this spec revision 1.0 to be ready around April this year. In the UBB, we need to define dimensions to be compatible with any chassis design for it. The chassis should be 19 inches and 21 inches rack compatible. We also define on the universal baseboard the number of modules that it can host and the maximum power that the module can support. Well, the range of power that the module can support. We define the number of high-speed interconnects to the host, the speeds, the number of interconnect on the scale-out interface, and also the speeds that are supported into that scale-out interface. We also define a set of signals that the main intention is to provide the book manageability and security features. We will go and dig into the power delivery of the system. So the power delivery of the system has the capability to support 12 volts and 54 volts. The reason of this is for modules that support up to 350 is cheaper to build a module that has 12 volts as an input. When you increase the power of the module, looking for more performance, you need to increase the frequency and then increase the power of the module. Then it becomes harder and harder to do it with 12 volts. So we also include in the spec the support for 54 or 48 volts to make more easy to define the power planes inside of the module. This provides the vendor for the different OEM modules to select which type of accelerators or markets they want to design for. Also, if you see the slide, we provide independent power rails for each one of the module in both 12 volts and 54, and this allows to provide differentiation between the different UBB vendors if they want to add power management, power telemetry, hot plug, other type of features to differentiate between different UBBs. On the side of the high-speed interconnects, we define the type of connectors that you can use for the host retimer and for the scale-out retimers, because you need to have a common set of cables to be. However, the host interface can be PCI Express or OpenCAPI, and the scale-out interface can be common Ethernet or a proprietary protocols. We include into the spec the capability to support retimers as an optional feature, because we give the flexibility of the vendors to decide to have a system that is highly tuned and only will interoperate with the same type of vendors, or you build a system that is more widely compatible and that is a little bit more expensive if you include the host retimers. On the mechanical side, we define location of the connectors, location of the mounting holes, maximum size of the heatsink for both the BRs and the module. We define the thickness of the booster plate, the thickness of the stack up, all to be compatible with thermal and mechanical features on the standard chassis. Right. Finally, I will talk about the interconnect topologies that the spec gives. The interconnect topology, each different interconnect topology will require a different baseboard, and that is highly defined by the type of problem you want to solve. Some of the neural networks require more connectivity between the accelerators, and other require bigger bandwidth between them. Then the spec provides two reference topologies. One of them, the first one, called fully connected, which provides the maximum flexibility at the price of limiting the bandwidth between the modules. And the second, the hypercube mesh, which maximizes the bandwidth between the modules, but is not fully connected. Then for some, from going from one module to another, sometimes you need to have two stages, increasing the latency between those two connections. On the fully connected, every module has a direct link to every other module. To illustrate the flexibility, higher flexibility of this, you see that if you use only half of the links, or 6 ports per module, you still can connect all the modules in a hypercube mesh topology. Right. If the UBB is 100% designed, limited to focus on the hypercube mesh topology, then you can maximize and have the double of the bandwidth for the scale out interconnect between the modules, and maximize the performance for that topology. Okay, this is what I came here to tell you. My request to you is get involved if you are part of this artificial intelligence hardware efforts. Please get in touch with the Open Compute people there in the conference and subscribe to our group. Thank you very much.
Hello. This is Jose Perez. I apologize for the technical difficulties. It seems that I put the wrong MP4 file to upload. So I take the blame for this. It's not a problem on the OCP Virtual Summit. Still there, you have seen or hear the presentation, and you're able to see the slides. It will be open for questions if you click on the question and answer tab.
Actually, Jose, let me chime in. Regarding the spec 1.0 release, I think right now we have the draft ready, but we still need to go through the IC and the team to make a final call so that we can release it. And we will update this document release in the OAI workgroup meeting. So anyone have a question for Jose or myself regarding the UBB spec? So the question for Ramaswamy, is there the support for 106 gigabit per second PAM4, right? I think for the UBB spec we have right now, we only target on the 56 gig PAM4, but it really depends on the baseboard design and in terms of the instancer loss, and it also depends on the PAM4 link budget as well. So you can send us an email with the detail, and then we can get back to you on that one, because we need to understand what is the budget that you have on the OAM and the spec of the PAM4 service, and then we can look into the UBB because because due to the material, right? And we need to understand what is the loss on the on the 106 gig PAM4.
Mm-hmm. Yeah, I agree. So, but I think the straight answer is from the UBB is standard or specification, the maximum speed support is 56 gigabit per second.
Yes, because the design is based on the 14 gigahertz clock, and we are targeting no more minimum of 14 dB for the 56 gig PAM4. So we can look into the detail and get back to Ramaswamy.
Thank you. Good question. There is another question. So it reads, what is the plan for PCIe Gen 5 support? So currently, there is no plan to include PCIe Gen 5 support. The main barrier, let's say, to include this into the UBB spec is the availability of the PCIe Gen 5 switches. Song, do you want to add something about that?
So the Gen 5 is also really depends on the design in terms of the OAM side, because right now we do not, we only thing that we can do is based on the PCI spec, and we still need to understand whether the UBB itself will have a retimer, and to look into the link budget, right? So if you do have a link retimer, I don't see that is going to be a problem, and we still need to look into that, because the UBB spec itself, we are not mandatory that you need to have a retimer or not, right? And also the routing on the UBB baseboard, what is the length of the trace length, right? And also the rotation of the OAM as well. And we still all the things still back to the question on the link budget, but based on our assessment on the UBB, I don't see that it's going to be a problem, but we need to look into the detail.
Okay, there is another question on the tool from Andre. What vendors are working on OAM UBB currently? Some maybe more.
So we have a few ODM which is working on the UBB right now. One of them is a High, Inspur, Inventec GT system. So those are the vendor working on the UBB, and you can check with them, and if you are interested. And in terms of the OAM, there are a few vendors that announce in the last Amsterdam summit, right? And Habana, I think, and Xilinx and other OEM supplier as well.
Okay. Any more questions? Okay. If no more questions, then I will give you some minutes back to get ready for the next session. Thank you very much.
Right. Thank you, guys.